Hi, wonderful people. We have an interesting geometry question to solve. So we are asked to find the value of the area of this quadrant. Please, this is not drawn to scale, and this is supposed to be a quadrant. So first, we need to figure out the formula for finding the area of a quadrant. Now, area of a quadrant is equal to 1 over 4 pi r squared, where your r is the radius of the circle or the radius of the quadrant, and pi is a constant. Okay, so that means that we are actually looking for just r, because once we are able to get the value of r, then we will be able to find the area of the quadrant. Please hit that subscription button, because trust me, you are going to love this particular channel and you wouldn't like to miss our next video. So hit the subscription button and turn on the notification bell so that you'll be notified anytime we upload a new video. Thank you. So at this point now, how do we go about it? So let's locate the radius on this diagram. Remember that any straight line drawn from the center of a circle to its circumference is a radius. So this is the center of this circle. If I draw a line to its circumference to this point, which happens to be the point of contact between this curve and this line, okay? So that means this is our radius. Now I'm choosing this point because it's a very important point on this diagram. I could have chosen from here to here, from here to here, all our radius, but there's a reason why I chose this point, and you're going to see that later. Now, if you look at this, you will notice also that AB is the radius of this quadrant, right? Yes, AB is also the radius. And that means that DC is also the radius, the whole of this, because this side is equal to this side, okay? Then also AD is equal to the radius because BC is also the radius, and opposite sides are equal. Now, but let us go straight to find to a theorem, the external tangent theorem. External tangent theorem. Now, what does this theorem say? It says that in a circle, if this is a circle, okay, and we have two tangents like this, and these two tangents meet at point P. Let's call this tangent AP, and let's call this tangent BP. Then according to this theorem, AP is equal to BP, that is their length from their point of contact, okay, is equal. Now if we look at this diagram, we have something like that here. Even though this is a hand sketch, so we may not actually get the exact length, but just know that this is a sketch, it's not drawn to scale. So using this external tangent theorem, you can see that E is our P, refers to our P here. Yes, because AP is a tangent at this point, and EG is a tangent at this point. So using this theorem, AE is equal to what? EG. Now, what is our AE? Remember that from here to here is 4, okay? So AE is equal to, the whole of this line is R, so the whole of this line is R as well. So it means that AE is R minus 4. So AE is R minus 4. And automatically, that means that EG is also R minus 4. Okay, similarly, let us look at this. We can see that F is the point of contact between the tangent FC and GF. Okay, this is F. So GF and FC are external tangents to this particular circle and they meet at F. So it means that FC is equal to GF. Now to get FC, remember that FC will be equal to, note that this is also the radius of this circle, right? So it's going to be r minus 3. So it's going to be r minus 3. So, and since FC is equal to FG, it means that FG is also r minus 3. So you're going to write that r minus 3. Now I want us to look at this. Let us draw this particular right angle out. Okay, so if we draw it out, we are going to have ED is 4, DF is 3. So we have ED 4 and we have DF 3. Okay, so this line now will be r minus 4 plus r minus 3. So the hypotenuse will be r minus 4 plus r minus 3. Now using the Pythagorean theorem, we can see that r minus 4 plus r minus 3 all squared being the hypotenuse should be equal to 4 squared plus 3 squared. So r plus r is 2r, minus 4 minus 3 is minus 7 all squared is equal to 16 plus 9. So we have 2r minus 7 squared is equal to 25. Now, let us take square root of both sides so that we can remove this square. Take square root of both sides. So we have 2r minus 7 all squared square root is equal to square root of 25. So this square will remove the square root. We have 2r minus 7 is equal to 5. Now we are taking only positive 5 because we're actually talking about length. So definitely our r is going to be a positive number. So we are actually taking the positive root 25. Okay. So 2r will be equal to 5 plus 7. If we transfer this to the other side, 2r is equal to 12. So if we divide both sides by 2, we will have that r is equal to 6. Now, let's go back to the diagram. The question says we should find the area of the quadrant. So this will be 1 over 4 multiplied by pi multiplied by 6 squared. We've gotten our r to be 6, right? So this is 1 over 4 multiplied by pi multiplied by 36. And when 4 divides 36, we have 9. So this implies that the area of the quadrant is equal to 9 pi. Thank you so much for watching. See you in my next video. Bye.